right, here we go. This is the second video from section 3.5. We are on number 5. This is on the second page of the 3.5 notes. So let's dive right in. This number 5 and number 6 are a little more tricky here. You'll notice that both of those have this e to the negative x right here, which is going to cause a little problem for us, but we can do it. All right, here we go. So to start with, on number 5, we're trying to solve for x. So I want to get this out of the denominator. So I'm going to multiply both sides by that 1 plus e to the negative x. And then I'll divide both sides by 4. 50 divided by 4 is 12.5. Let's isolate this term with the e to the negative x, so I'll just subtract 1 from both sides. And then we've got an x in a exponent, so to get rid of that, we take the log of both sides. So I'll just do that right here. And on the left, we get the natural log of 11.5. On the right, the natural log of e to the negative x is just negative x. And then divide both sides by negative 1. So x is going to be the opposite of the natural log of 11.5. So if I go over to my calculator then, and just take the opposite of the natural log of 11.5, that gives me about negative 2.442. And that's my result. So that one wasn't too bad. The tricky one is this next one over here, number 6. So let's look at that one. We've got e to the x plus e to the negative x all over 2 is equal to 4. So first thing I'm going to do right away is just multiply both sides by 2. And then remember what this means right here. When you have e to the negative x, that is 1 over e to the x. I couldn't just take the natural log of both sides as it is, because if I did that, I would have something like this. I'd have the natural log of this right here equals the natural log of 8. But you can't distribute that natural log. Remember, we talked about that before. So therefore, you're not going to be able to simplify this at all. So that's why we want to just avoid doing that. That doesn't help us at all, really. Oh, no. Okay. Let me get back here to my blue pen. All right. Now, what I would probably do at this point is I want to get rid of this denominator being e to the x. So I'm just going to multiply both sides by e to the x, like so. Oops. So therefore, on the left here, I'm going to have e to the x times e to the x, which is e to the 2x. Adding exponents. And then if I have e to the x times 1 over e to the x, that's just 1. And then over here we have 8e to the x. Now, I'm going to subtract the 8e to the x over to the other side, and I think you will see why once I get it over there. Do you notice that this is quadratic in form? Here you have e to the x, and here you really have e to the x squared, or e to the 2x. So we're going to have to solve this like a quadratic. Now, if there were two numbers that had a product of 1 and a sum of -8, we could easily factor it. However, I can't think of any that would work for, so I'm going to have to use the quadratic formula. When you use the quadratic formula here, you're not solving for x quite yet, you're solving for e to the x, because that's what's being squared. That's what's being raised to the first power. So you're going to have e to the x is equal to -b, which would be 8, plus or minus the square root of b squared, -8 squared, 64, minus 4 times a, which is just 1, times c, which is 1, all over 2a. That gives me e to the x equals 8 plus or minus. Here you just have 64 minus 4, which is 60, all over 2. And then what I would do at this point is just put those in my calculator. So let's go over there and do that. We have, let's see here, 8 plus the square root of 60 over 2. So that's about 7.873. And then if we do the same thing but change it to minus 8 minus the square root of 60 over 2, we get 0.127. So let's put both of those in to our equation over here. So e to the x is equal to either 7.873 or e to the x is equal to 0.127. And then finally, at this point, that's where we take the log of both sides. So think about if I were to take the natural log of both sides. Of course, the natural log of e to the x is just x. And same thing down here, you get the natural log of 0.127. And then we would just put both of those into our calculators. So we have the natural log of this 7.87 number. That's one of our solutions. And then the other one is the natural log of this number. And that's our other one. And notice that these two are opposites of each other. That will always happen on these problems that are set up this way, where you have e to the x plus e to the negative x. Obviously, if 2.063 works, so does negative 2.063 because it's just negated over here. So those are our two x values. And that would be our solution. Now, this problem is a lot more algebraically rich, I guess you would say, than some of the previous ones. So sometimes you may want to, to kind of avoid all this algebra. One thing you can do is just graph it to begin with on some of these. So let's try number 6 on our graphing calculators. So what you would do is go into your y equals. I'm going to make sure up here at the top that I turn off my plot. You just go up there on and highlight the plot that's on and hit enter to turn it off. A lot of times people come up to me and can't figure out what's wrong on their calculator, and it's that one of their plots is on. So I'm just going to graph the left-hand side of the equation for y1, which is e to the x plus e to the negative x divided by 2. And on my y2, I'm going to graph the right-hand side of the equation, which is just going to be a horizontal line at y equals 4. So let's just zoom standard and see what happens. Sometimes you may have to change your window after that. Looks like it's going to work just fine this time. So in the blue, you see the graph of the left-hand side of the equation, and the red is the right-hand side of the equation. And so now we'll just find those intersection points. Second trace. And we're going down to number 5 here, intersect. It asks you to pick the two curves that you want to find the intersection of. Right now I'm on the blue one, so I'm going to hit enter. That's my first curve. Now I'm on the red curve, so that's the second one. Hit enter. And then you go over close to the intersection point and hit enter. And there you see that our intersection is at x equals 2.063, which, no surprise, 2.063 was one of our solutions over here. The other solution is negative 2.063, and that would be this other intersection point on the graph here. So on some of these, you may want to do them graphically. Just make sure you pay attention to directions on a quiz or something. If I say, you may solve it either algebraically or graphically, that would be fine. Otherwise, you're going to need to just do it however you want. But if it says do it algebraically, you need to do it algebraically. Okay, I think that is all then for this section. At this time, you should be able to do those homework problems that I have listed down at the bottom of your handout there. So try to do those for tomorrow. And then tomorrow we'll talk about how to solve logarithmic equations. Have a good one.